Welcome to the fascinating world of probability. Today, we are diving deep into one of the most fundamental yet transformative concepts in statistics, the multiplication rule for dependent events. This isn't just a formula, it is the mathematical bridge that leads us directly to the logic of Bayes' theorem, a tool used everywhere from medical diagnoses to self-driving cars. To understand dependency, let's first look at independence. In independent events, like flipping a coin twice, the outcome of the first flip has zero influence on the second. But in the real world, things are rarely that isolated. Dependency occurs when the occurrence of one event changes the probability of another. Think of drawing two cards from a deck without replacing the first one. The second draw is aware of what happened before. Let's formalize this with the general multiplication rule. For any two events A and B, the probability of both occurring is the probability of A happening, multiplied by the probability of B happening given that A has already occurred. Mathematically, this is expressed as P of A and B equals P of A times P of B given A. That vertical bar is the symbol for conditional probability, the heart of our discussion. Imagine a medical scenario. Suppose 1% of a population has a specific condition. Let's call this event B. A diagnostic test, event A, is 99% accurate if you have the disease, but also has a 5% false positive rate. To find the probability that someone has the disease and tests positive, we must use the dependent rule. We don't just multiply 1% by the test's overall accuracy, we must look at the conditional link between the infection and the test result. This logic is the foundation of Bayes' theorem. If we know that P of A and B is the same as P of B and A, we can set two equations equal to each other. P of A times P of B given A equals P of B times P of A given B. By rearranging this simple equality, we derive the famous Bayesian formula. It allows us to update our beliefs, the prior, based on new evidence, the likelihood. In modern technology, this rule powers spam filters. When your email provider sees the word free, it doesn't just look at that word in isolation. It calculates what is the probability this email is spam given it contains the word free. By chain linking these dependent probabilities, AI can categorize millions of emails with incredible precision. As we've seen, the multiplication rule for dependent events is more than a calculation. It's a way of reasoning through a connected world. From clinical trials to the algorithms in your pocket, the logic of conditional probability and Bayes' theorem remains the gold standard for navigating uncertainty. References: 1. Sheldon Ross, A First Course in Probability. 2. John E. Friend, Mathematical Statistics. 3. James G. Kabelflesch, Probability and Statistical Inference.